welcome back, everybody. Welcome back. Today we will discuss the Egyptian arithmetic, more in particular with fractions. We will multiply fractions. We will divide fractions. Today we're going to learn in depth of how the Egyptians did these computations. Now, let me remind you, as my partner mentioned earlier, the Egyptian arithmetic is essentially additive, meaning that its tendency was to reduce multiplication and division to repeated addition. Now, let me take this a step back and show you how they did a division problem. Because in order to know how to do fractions, you have to be able to do multiplication and you have to know how to be able to divide. So 91 divided by 7 will be my first problem. (91) divided by 7. Now the way the Egyptians divided, is they would take the 7 and they would double that, and double that. Which you would basically take you would double the factor that comes before it. You started with 7, you double it, you get 14, you double that, you get 28 and 56. Now you always start with 1 on the left side, you double that, you get 2, double that, you get 4, and double that, you get 8. Now, once you get to a certain point to where you think you might have enough, you can stop and you will add these factors on the right side to try to give you your dividend, your 91. Now, if you add 7, 28, and 56, that will give you 91. So its corresponding factors are 1, 4, and 8. And if you add 8, 4, and 1, you will get 13. And now 13 is your quotient. 13 is your quotient to 91 divided by 7. Okay. When you divide and it goes into perfect, that's great. But we all know that life is not perfect. We know that there's numbers that will give you a headache, that will not go in perfect. So, for example, let's look at 35 divided by 8. Now, we know that 8 will not go into 35 perfectly, but we will use division, as the Egyptians did, to figure out what the remainder is. So, you will start off the same way. You will start off with the 8, then you will go to 16, and you will go to 32. And now, the trick about this, the way the Egyptians did it, is that they will double up until you get close to what your dividend is. So 32 is close to 35, but it can't go over. If you've gone over, then that's basically an extra step that you didn't need. So you go all the way to 32 because it's close to 35. The next step, first you double. The opposite of double is you take half. So the next step is you're going to take half of the 8, which would give you 4, and then you would have a 2, and then you would have 1. Half of 4 is 2, half of 2 is 1. And as always, you start with 1 on the left side. If you double 1, that'll give you a 2. Double 2, you get a 4. Okay? Now, as I mentioned earlier, the opposite of doubling is you take a half. If you started with 1, half of 1 is 1/2. Half of that is 1/4, and half of that is 1/8. Now, you're trying to add these factors on the right side in order to get you your dividend, which is 35. Now, if you have 32 plus 2 plus 1, that will give you your 35 that you're looking for, correct? Okay. Now, its corresponding factors is 4, 1/4, and 1/8. So, if you add those, 4 plus 1/4 plus 1/8, you will get 4 and 3/8. And that, my friends, is your quotient with your remainder turned as a fraction to your problem, 35 divided by 8. Now, when the Egyptian mathematicians needed to compute with fractions, they were confronted with many difficulties. Their computational practice allowed them only to admit so-called unit fractions, that is, fractions that were 1 over n, where n stood for any natural number. Now, they had The Egyptians indicated a unit fraction by placing an elongated oval over the hieroglyphic for the integer that was to appear as a denominator. For example, if you have 1/4 as your fraction, the way the Egyptians wrote their numbers is this would represent 4 in Egyptian math. So if you have 4, to change that to 1/4, you would have an oval or an ellipse, as to say, over the 4th, and that would equal 1/4. Now, this was how they this is how they wrote their fractions, with the exception of 2/3, for which there was a special symbol that looked like this. 2/3 looked like that. That was the 2/3 is the only fraction that could have a number on the numerator that was higher than 1. And for every other fraction, they had to be decomposed into sums of unit fractions, each having a different denominator. For example, if you have 6/7, the easy thing to do here would be 1/7 That would be the easy thing to do. But the Egyptians didn't like common denominators. So therefore they would change 6/7 into something crazy, into something that would make you scratch your head. Now the way they would have this is 1/2 plus 1/4 plus 1/14 plus 1/28. Now when you look at it, it's kind of odd. But using your common denominators, using what you know, it does equal 6/7. Now, they did this because they did not want common denominators, as I mentioned. The Egyptians would have thought it both absurd and contradictory to allow such representation. In their eyes, there was one and one part only that could be the 7th of anything. The ancient scribe would probably have found the unit fraction equivalent of 6/7 by the following conversion of 6 by 7. So let's look at that. Let's say we have 6/7. We are going to try to find your equivalent fractions as Egyptians would. You have 6/7, correct? Okay. Well, your numerator would be 6 and your denominator would be 7. Your numerator would be your dividend and your 7 would be your divisor. Therefore, when you were dividing earlier, that problem that I did, you double your divisor. In this case, your divisor is a 7, correct? 7, when you double that, you get 14, and when you double that, you get 28. Now, that would be so if you were dividing. If you were trying to go into a bigger number, such as, say, 35 or 40. But since we're trying to go into a smaller number, we need to start taking halves. Now, if you take half of 7, you would get 3.5. 3 plus 1/2. Now, if you take half of that, if you take half of 3, you would get 1 plus 1/2. And if you get half of 1/2, you would get 1/4. Now, this can keep reducing, but in order to get let's say, a pretty number, for example, let's do a 1. Okay? We'll do a 1, and half of 1 is 1/2. And half of 1/2 is the same as 1/4. Okay? Now, you will start off with 1 as always on the left side. Start off with 1. Half of 1 is 1/2. Half of half is 1/4. Now, since I started off with 1, my original number is 7. This is 1/7 of the original number. Therefore, this is 1/7. And If you take half of 1/7, you would take 1/14. And if you take half of 1/14, you would get 1/28. Now, in order to add this all up, to try to get your numerator, your dividend, which is 6, you would get 3 1/2, add 1/2, 1/4, 1/2, and 1/4. Because let's look at that. 3 plus 1/2 plus 1 plus 1/2 plus 1 plus 1/4 plus 1/2 plus 1/4. Okay, it's a really long part, but let's break it apart. 3 and 1, you get a 4. Half and half, you get 5. Right? 3, 4, and this half and half is 5. And then you get a half and a half is 6. You have 5 plus 1/2 plus 1/4 plus 1/4, which is the same as 6. Now you have your denominator, and we use that by taking half, by dividing with fractions, in order to get your numerator, which in the end is the same as your equivalent fractions. Now this handsome gentleman in front of me, he will take you on in further depth into the way the Egyptians did math, and if you would be very kind to him, he will be more than glad to help you out.